Okay, then we're going to do at pi over 3. We're going to see what the cosine is at pi over 3. At pi over 3, our cosine is 1/2, or 0.5. At pi over 2, our cosine is 0. At 3 pi over 2, our cosine is negative 0.5. At 5 pi over 6, oopsie, our cosine is a negative 0.9. Okay, everyone keep going. I'll put the okay, at pi we should be at 1. At 7 pi over 6 we should be at 0.9, negative 0.9. At 4 pi over 3 we should be at negative 0.5. 3 pi over 2 we should be at 0. 5 pi over 3 we should be at 0.5. 11 pi over 6 we should be at 0.9. And at 2 pi we should be back at 1. And so this is my cosine curve. Okay, compare this to our sine curve. So write down some things that are similar, things that are different between sine and cosine. Again, this is our sine curve. That's cosine. Sine. Cosine. Write something down, please. It's up here, fine. Just write it above here. Sine and then cosine. What is the same? What's different? Something.
Their curves are different because sine starts at 0 and cosine starts at 1.
Okay. Go. Isabel, what did you write down? Anything different? Nothing else? Yeah.
For cosine, you go downwards, or you go negative, while at sine you go positive.
Okay. So it starts at a positive and goes down to a negative. Cosine starts at positive, then goes down. Sine goes up first, starts at 0 and then goes up to positive amplitude. Which one?
The one you just said.
Mm-hmm.
Because you feel the negative in your columns
true, but sine would then go down. It would still be opposites of each other. Yes. It's not 100% true, but in this graph it is. Correct? Anything else? Anyone say something else? Yep.
Well, cosine starts at 1, and at 1 and sine started at 0.
Okay. Starts and stops at 0. Starts and stops at 1. Okay. Yep.
Only have one curve.
Yeah, this has one little like curve to it, whereas sine has a curve up and then a curve down. Okay. If this continues, cosine will continue. It'll start having that same curve. It's just going to start up. So this is cosine. Sine is this. Oh, we should do, yeah.
Would it be better if you did like 2 for every 1? Like, if you went up and
Yes.
it would be end up.
Well, you can see the differences. They look very similar when you put them right next to each other and have multiple periods. Okay, the only difference is cosine starts at the top and sine starts at the 0. Okay, any questions over that? So we now need to fill in all of this again. It's the same information that we got from sine. So the A is the amplitude. Oh, wait, hold on. Okay, so write that in. The only difference is this is get cosine now on your page. But the amplitude is still A, and it's how high or low the function goes from the midline. Okay, the frequency then is the number of cycles between 0 and 2 pi. How many times you're going to see that cosine curve. The period then is 1 cycle, the length of times it takes a periodic function to repeat. So it starts at 1. How long does it take to get back to 1 for cosine? Okay. And the midline is the line that is equal distance from the maximum and minimum of the sine curve. For today, we're not translating it at all, so it's still y equals 0 is the midline. And your period is still 2 pi divided by b. Are you done copying? Okay. Okay, so let's do what we did yesterday or on Tuesday. We're going to given the cosine function, find the amplitude, the frequency, the period, and the midline. Esmeralda, what's the amplitude here? Then we want the frequency. What is it? The B value equals 1. Then we want the period, which is 2 pi divided by B. Brian, what's the period then here? 2 pi over 1, which is equals 2 pi. And again, the midline for now is always y equals 0. For today, y equals 0. Okay. Any questions over that? In your homework, they're also going to ask you about the range. So let's write that in. Get a different color. Can someone raise their hand and remind me what range is? What does range represent? Not the x. That's the domain, is the x values. So what's the range? The y. How high and how low it goes. So how high and how low does this go? 3 to negative 3, right? It's going to go up to positive 3 and down to negative 3 because the amplitude is 3. So the range is negative 3 is less than or equal to y is less than or equal to positive 3. That's the range. The y is in between negative 3 and positive 3. That's how you write it mathematically. Yes?
But the frequency for that value say negative?
It's, sorry, it shouldn't say, that's just a mark. Yes, Brian?
Does it always have to be like that, the object, the y?
Yes. That's how you notate range. That's in between two values. Okay, next one. Class, what's the amplitude? Class, the frequency? Very good, 1/2. Okay, so let's review how to do the period when we have fractions. It's 2 pi divided by 1/2, which equals, yes, 2 pi you're going to multiply by the reciprocal of 1/2, which is 2 over 1, or 2. So 4 pi is the period. Any questions over that? Okay, we'll get there. So the midline class, what is it? Y equals 0. It has to be y equals 0. It cannot just be 0 because that's just a point. We want a line. Okay. Then we want the range. It's 2, right? It's going to go up to 2 and down to, so negative 2, less than or equal to, y is less than or equal to positive 2. Okay. Yes, it did. The smaller value goes first, y is in the middle, larger value next, and the inequalities always are less than signs. Okay, do the next one on your own. Correct. So everyone pretty much got this. The amplitude is 1. Okay. The frequency then is 1/3. The period then was 6 pi, because 2 pi times the reciprocal of 1/3 is 3 equals 6 pi. Midline, y equals 0. And then the range is -1 is less than or equal to y is less than or equal to 1. Any questions over that? Very good. Okay. Now let's graph this. Okay, we're going to do the same steps we've done with sine. Okay, we're going to do the same steps with cosine. Well, they were in the right order when we picked them up.
So yours one too? Yeah.
They're numbered, so just find page 8 now. Okay? It's okay. Is it 7 for you guys? Page 7. Find page 7 then. Sorry. Yours is... There we go. Find page 7 then. Sorry. Okay, Jacob, what's the amplitude? Or the A value? 1. Okay. Then we need to find the period, which is 2 pi divided by b. So this is 2 pi divided by pi over 2, because the b value is our pi over 2. So we do 2 pi times 2 over pi, the reciprocal, which gives me 4 pi over pi, which is just 4, because the pi's will cancel out. Any questions on how I got that? Okay, so remember to label our x-axis. To count the x-axis, the period divided by 4 on the x-axis. So my period was 4. I'm then going to divide it by 4, which gives me 1. So this is nice. I'm just going to count by 1. 1, 2, 3, 4, 5, 6, 7, 8. This is 1. This is 2. This is -1. This is -2. Any questions over that? Okay, so now we're going to do our t-chart like we did with our first sign. So we're going to pick a number for theta, plug it in.
Wait, I have a question.
Yes.
How did you know to count by period divided by 4? Is it always divided by 4?
Always divided by 4. That's just like a formula. Any other questions? So cosine of pi over 2 times theta. So I'm going to start by plugging in 0. I'm going to have cosine of pi over 2 times 0. You want to multiply this together first. So pi over 2 times 0, class, is 0. Good. So we just want the cosine of 0. We're going to find our unit circle. And the cosine of 0 is 1. So I'm going to graph where x is 0, y is 1. Any questions over that? Okay, then we're going to plug in our next point, which is 1. Our next x value is 1. So I'm going to do the cosine of pi over 2 times 1, which equals the cosine of pi over 2. So we're going to go back to our unit circle. The cosine of pi over 2 is 0. So I'm going to plug in 0 here. Okay. Then we're going to plug in 2. We're going to do the cosine of pi over 2 times 2, which equals the cosine. The 2's will cancel out, and I'll just get pi, the cosine of pi. Go back to our unit circle. The cosine of pi is negative 1. Nope. Plug in 3. Then make another chart next to it. This was 0, and this was negative 1. Okay, 3 now. The cosine of pi over 2 times 3 equals, the 3 is over 1, so when you multiply it out, it's going to be 3 times pi, which is 3 pi. And then 2 times 1 is 2, so 3 pi over 2. Go back to your unit circle. Let's see, not that way, this way. And the cosine at 3 pi over 2 is 0. Any ideas on where it's going to go to next? 1, good. Then what? Then what? Then what? Make sure your lines are curvy and not like V-shapes. And that's our cosine curve. It looks very similar to sine curve, right? The only way you're going to tell the difference between cosine and sine at this point is cosine at 0 and sine at 0 are going to be different. Cosine starts at 1, sine starts at 0. That's how you can distinguish between the two. Any questions over that? Okay. Next one. Okay, negative 3 cosine of theta. We still need our A value. Kayla, what's the A value? Negative 3. So that tells me I'm going to go down first instead of up because this is reflecting across the midline. The amplitude is the A value can be negative. Okay? Because the amplitude refers to a distance. The A value talks about a number. We didn't, right. Yeah, It won't ask you to. Okay, then the period. Okay, Stephen, what's the period here? 2 pi, and the b value is 1. So it's just 2 pi. Okay. Then we're going to count by. Again, it's the period divided by 4. So it's 2 pi divided by 4, which equals 1/2. Pi over 2, or 1/2 pi. Reduce that better. Or do the counted by? Yeah, okay. Any questions over that? Okay, so we're going to count. Pi over 2. Again, this is probably the hardest part for you guys. Then another pi over 2 is 2 pi over 2, which is pi. Then another one is 3 pi over 2. Then another one is 4 pi over 2, which is 2 pi. Another one is 5 pi over 2, which is, and then this is 6 pi over 2, which we can reduce to 3 pi. This is 7 pi over 2, and then this is 8 pi over 2, which is 4 pi. Any questions over that? Okay, then we're going to count 1, 2, 3, 4, -1, -2, -3, -4. Any questions over that? Okay, let's do our pattern of cosine. So instead of plugging in all those numbers like we did in example D, we're going to memorize a pattern. And hopefully you can memorize it because it's much easier than plugging all those numbers in. So cosine is going to start at 0 and the amplitude, or the A value, 0A. So in this case, it starts at 0 for x and -3 for y. Then it's going to go to 0. Okay. So then it's going to go from there. It's going to go to the negative A value, negative A. So this is already negative, so negative A times -1, or -3 times -1 is a positive 3. You're going to go back to 0. Then we're going to go back to A. Go back to the A value. So then in this case, it's at -3. Then you're just going to repeat. So the last step is to repeat that again. Okay, so back to 0, positive, 0, negative. And again, make your curve, your lines curved. Any questions over that? We're all good? Yes.
Is the A the amplitude?
A, yes, and no. Because amplitude is technically a distance, and A can be negative, so and a distance can't. So A is just the number in front of the cosine, whatever that is. Any other questions? Okay.
That just makes the object smaller.
Yes. The distance is still not negative, it's the direction in which it's going. That's negative. Okay, so we have our amplitude being 2. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, then the period would be 2 pi divided by the b value, which was 2, which was pi. So then we're going to count by pi over 4, because we have to divide the period by 4. So this is pi over 4. This is 2 pi over 4, which is pi over 2. This is 3 pi over 4. This is 4 pi over 4, which is pi. 5 pi over 4, 6 pi over 4, which is 3 pi over 2. 7 pi over 4, 8 pi over 4, which is 2 pi. Okay. Then our pattern starts at the amplitude of 2, goes to 0, negative 2, 0, 2, 0, negative 2, 0, 2. Any questions over that? We're good? Okay, now we're going to write the equation of cosine. So again, our equation should be f of theta equals a times the cosine b theta. Nadine, what is the amplitude? Very good. So the A is easy, it's just 2, because that's how far up and down I went. The B value is a little hard. You want to find the period first. So the distance it takes me to go one complete sine curve. Where am I going to stop at?
No, 7. No, 8.
At 8. I want to go from 2 back to positive 2. That's how I know it's one complete cycle. If I started at 2, I want to make sure to get one complete cycle, I want to stop at 2, so it doesn't keep repeating anymore. So the period equals, is that 8? Okay. Remember the period, the formula for period? Equals 2 pi over b. In order to get that b value, I take what the period is, 8. I set it equal to my formula of 2 pi over b. I make this over 1, and then I cross multiply. b times 8 is 8b. 1 times 2 pi is 2 pi. Divide by 8 to get the b by itself. And I get b equals, we can reduce this both by 2. So it's going to be pi over 4. Not the period, the frequency. It's the b value. The period was 8. So now I'm going to plug that back into our formula. F of theta equals the A value times the cosine of pi over 4 times theta. That's it. That's your answer. Okay. Any questions over that? Okay, now I'm going to graph secant. Secant and cosecant look very similar because they're reciprocals of sine and cosine. Okay, so we're going to graph the reciprocal of cosine. So here's your cosine, your basic cosine curve. Remember when cosine or cosine of theta equals 0, secant equals undefined. Okay, or it's an asymptote. Okay, in this case when we graph it, it's going to be an asymptote. Okay. Because if cosine is 0, the reciprocal of that is 1 over 0, which is undefined. Okay, so we're going to graph this. So here, cosine is 0, so there's an asymptote there. And here, cosine is 0, so there's an asymptote there. Any questions over that? And since cosine is just the reciprocal, since this curve goes down, you're going to flip it up. And it's going to go up. You're taking this curve and you're flipping it down because it's the reciprocal of it. So they'll share that max and min point. And then this one too. Since this is just right here, you're just going to flip that one part up. And it's going to go up like this. If it kept going, you would complete that curve over here. But it's not on your graph really. Any questions over that? Okay. Let's graph one without the cosine. Okay, so in order to graph this, you want to graph the cosine first. Okay, so you're going to start with the A value. Class, what's the A value? Okay. Then you're going to go with the period. This one's going to be a fun one because it's going to be a crazy fraction. And that's okay. The period's going to be 2 pi divided by 3, which is just 2 pi divided by 3. Then you're going to take 2 pi divided by 3. To count, you want to divide that by 4, which gives you 2 pi over 3 times the reciprocal of 4. What's the reciprocal of 4, class? Oh, good, 1/4. You multiply across, and you get 2 pi over 12, which is pi over 6. So this is going to be 1, 2, 3, 4. This is going to be -1, -2, -3, -4. This is going to be pi over 6. what's the next one going to be then? 2 pi over 6, so pi over 3. Then 3 pi over 6, which is pi over 2. Then 4 pi over 6, 2 pi over 3. Then 5 pi over 6. Then 6 pi over 6, which is pi. 7 pi over 6. And finally 8 pi over 6, which is 4 pi over 3. Any questions over that? Then you just need to do the pattern of cosine. I start at the amplitude. I go to 0. Then I go to the negative amplitude. Then I go back to 0. This. Keep repeating. Okay, you don't really need to draw on the curve. Okay. You need to write in the asymptotes. Or graph the asymptotes.
That's where it touches zero, right?
Where cosine is 0. So that would be here, and here, and here, and here. Okay. Then graph the U shapes. At the maximums. So here, my U is going to go here at this maximum. Here's another minimum, so it's going to go down. Another maximum, so it's going to go up. Minimum down. Maximum up.
Let's do this for every graph.
For cosec or for secant graphs. Yeah, cosine is the sine curve, or the cosine curve. Secant are these parabolas, shapes. Not really parabolas, but kind of looks like it. Any questions? Good job. Okay.